Now, this first chapter, Chapter P, is kind of going over some of what we've covered already. It's more of our review. Now, the first thing we're reviewing over are the real numbers and their properties. Real numbers can be described quantities in everyday life such as age, miles per gallon, and population. Symbols such as these here. All of these are considered real numbers. Here are some of the subsets. Each member of subset B is also a member of set A. Each member of set, Of the real numbers, the three dots called ellipsis points indicate that the pattern continues. So 1, 2, 3, 4 is a set of natural numbers. So we did this in Algebra 2. We started off the year with these. All right. 0 is our set of whole numbers. Positive, negative is our set of integers. Any number is a rational number where it can be written as a fraction. For instance, 1/3, 1/8, 125 over 111. They're all rational numbers. Any number we can write as a fraction. The decimal representation of a ratio number either represents, there's repeats as this here, or it terminates. So either a number is a repeating number, either be it 3 digits, 4 digits, or 1.3 repeated, or it terminates, it has an ending point. Any number that does not or cannot be written as a fraction is considered irrational. Irrational numbers have infinite non-repeating decimals, decimal representations. For instance, the number square root of 2 or pi are considered irrational, and we use the approximate sign instead of the equals. There's approximately equals to. And this is kind of the breakdown of our overall system, because our real numbers comprises of the irrational and rational. Rational, we have integers and non-integers. Our integers, we have positive and negative, negative and whole, natural and zero. Well, this first thing we're going to be looking at, so you hopefully we have something to write with. So, natural numbers. So as we look at all of these here that are listed in this set, which one of these would we consider to be the natural numbers? 7. Yeah, 7 would be natural. What else? Unfortunately, 0 would not be a natural number. 0 would be a part of the whole numbers. So are there actually any other natural numbers? No, it's just 7. Whole numbers would still be 7 and 0. So whole numbers are our natural numbers plus 0. That's the only thing it adds. Integers. This here is our positive and negative counting numbers. So we'd still have 0, we'd still have 7. But what else would we include from this here? -1 and -13. Rational. Well, we'd still have what? 0, 7, -1, -13. What else? -1/3, because rational are talking about ratios, our fractions, and 5/8. Questions on natural whole numbers, integers, or rational numbers? And the last one we had is irrational numbers. Well, not all of them are considered irrational. Because 0, 7, -1, -13, -1/3, and 5/5 are rational. Irrational, well, that only leaves a few things that are irrational. One of them is pi, square root of 2, and negative square root of 5. Because negative square root of 5 and the square root of 2 cannot be written as a repeated decimal or as a decimal that terminates. Both of these are non-repeating, non-terminating decimals. And that's it. Questions on these here? So, natural number was 7, whole numbers were 0, 7. Integers, -13, -1, 0, 7. Rational, we added -1/3, 5/8. And our negative square root of 5, square root of 2, and pi are our only irrational. Real numbers, we can represent them graphically on the real number line. When you draw a point on the real number line that corresponds to a real number, you are plotting the real number. The point 0 on the real number line is considered the origin. Numbers to the right are positive, numbers to the left are negative. The term non-negative describes a number that is either positive or 0. As illustrated, there's a 1-to-1 correspondence between real numbers and points on the number line. Every point on the number line corresponds to exactly one real number. So we have rational, irrational, integers, natural numbers, whole numbers. All of them are contained on the number line. I think y'all found this part of the page. Yeah, I mean, we're going to go through this pretty quickly. A lot, or parts of chapter P aren't going to take us too long to get through. Well, there's 0. -7/4. So this could be -2, so -7/4 is going to be somewhere close to -2. Now we could change -7/4 into a decimal if we want to make it a little bit easier. -7/4, approximately -1.75, so we're close to -2. So that's our A. This here. B, 2.3. We can say 1, 2. Well, 2.3 is going to be a little bit after 2. Now on this here, and when you do this on the homework, I'm not looking for precise that you are to scale. Just looking to make sure that it does look like where it should be. That you don't put a point way close to 3 for 2.3. Where would C locate or be between? So 2/3 would be between 0 and 1. A little bit closer to 1 than 0, just 2/3. And -1.8. Is going to be in between our -7/4 and -2. Because -7/4 was -1.75, so it should be between it and -2. It's been a while since y'all plotted things on a number line. Probably looking at what, 3 years? Probably Algebra 1, 8th grade. Questions on plotting numbers on a number line? Yep. That's about what we got. Ordering real numbers. One important property of real numbers is that they are ordered. Definition of ordered real numbers: if A and B are real numbers and A is less than B, where B dash A, B minus A is positive. The inequality A is less than B denotes the order of A and B. Okay, I'm going to stop there for a second. So A and B are real numbers and A is less than B. So A is smaller than B. Well, if I take any number and subtract the smaller number from the bigger, we should end up with a positive number. As if B is 10, A has to be less than it, so 9. 10 minus 9 is 1. No matter how we write it, it's always going to end up positive. The inequality A is less than B denotes the order of A and B. The relationship can also be described by saying that B is greater than A and writing B is greater than A. The inequality A is less than or equal to B means this here, and the inequality B is greater than or equal to A. As that's there, we have our 4 symbols. Geometrically, this definition implies that A is less than B if and only if A lies to the left of B on the real number line. That's a whole lot of words that just pretty much show this is here. This here is true in all cases. Whatever value A and B are, A is less than B, so on a number line, A has to be to the left of B. That's all it's saying. A lot of words. All right, Cooper. You ready for this? Place the appropriate symbol, less than or greater than, between the pairs of real numbers. So -3 and 0, would it be? Laren. Yes. London. 1/4 less than 1/3. And Abby. -1/5 and -1/2. Almost. Because if we think of them as a decimal, so here, -1/2 is -0.5, yes? -1/5. That's -1/2. -1/5 is -0.2, yes? So if I graph these on a number line, 0, we have 2 out here. Which one's closer to 0? The -0.2 and then the -0.5, yes? Because this is our -1/2. This is our -1, yes. So it's kind of the flip for negative. Because the bigger a negative is, the smaller it is. But yeah, so if it had been 1/5 and 1/2, yes. 1/5 is less than 1/2. Negative flips it on its head. Describe the subset of the real number of each inequality and then graph it. So if we're talking about this here, x is less than or equal to 2. What are we talking about? The set of numbers that are what? Less than 2. Less than or equal to 2. That's why I do this most times. I'm trying to remember if we want to do this in words or symbols. That's what probably we got there yet. Yep. Yeah, so it denotes let's write saying better. Describes all the numbers less than or equal to 2. Now, if we're graphing it, we need a number line. We also need the point. Now, at 2, would it be open or closed? Closed, because it is equal to, and then we would shade to the right or to the left? Left, because we're talking about less than. Questions on this here? Negative 2 is less than or equal to x is less than 3. So we'd be talking about what? All real numbers great or than or equal to negative 2 and less than 3. Now, like I said in Algebra 2, I'm not going to make you give me a 0 for reference and try to make this to scale. We just need our endpoints. We just need the key points on the line. I will say also you do need to make sure it makes sense, because smaller numbers go on the left, bigger numbers go on the right. Now at negative 2, would it be open or closed? Since it is equal to, it would be closed. 3 would indeed be open, because there is no equal to. At negative 2, we do have equal to, so it is closed. At 3, we do not, so it is open. And then we shade in the middle. Questions on any of this here? Now, we haven't gotten to it, but we've done this before. If we talk about this as an interval notation, our first one would be negative 2 to infinity, because we're going, it is unbound, decreasing all the real numbers that are less than negative 2. So we'd have negative 2, negative infinity, comma, 2. Since 2 is included, it is a bracket. We will never put a bracket with infinity, because again, there is no way to get to infinity. Infinity is not actually a number, it is the concept. In our other one, we would have negative 2, comma 3. 3 would have a parentheses, and negative 2 would have a bracket, because it is included. Questions on this here? We good with this so far? Ordering real numbers and inequalities can describe subsets or real numbers called intervals. In the bounded intervals below the real numbers A and B are endpoints of each interval. The endpoints of a closed interval are included in the interval, whereas the endpoints of an open interval are not included. So our first one, A comma B is closed. They are included, so A is less than or equal to X is less than or equal to B. Parentheses A comma B is open. And then we can have one of each. And we've talked about these before. This is nothing new. But then we also have unbounded intervals, so it can continue in one direction or the other, or it could be the whole line. And we we have these three here. For x is less than or equal to a, or greater than or equal to a, x is greater than a, x is less than or equal to b, x is less than b, or the whole number line. Questions on this here? The inequality c is less than or equal to 2 can be represented by the statement as, or represent the statement c is at most 2. The inequality -3 is less than x is less than or equal to 5 can be represented x, all x in the interval -3, 5. Just different ways we can represent those there. Questions on any of this here? All right. Absolute value and distance. The absolute value of a real number is its magnitude, or the distance between the origin and the point representing the real number on the real number line. All right. Now our definition of absolute value. If a is a real number, then the absolute value of a is defined as this here. So the absolute value of a is equal to a if the value of a is greater than or equal to 0. So if a is a positive number or 0, it comes back out as a. Now if a is less than 0, we have negative a. And it's actually very tempting to want to say negative a, but notice in this definition that the absolute value of a real number is never negative. What they're saying this here is not negative a, but the opposite value of a. So if a is negative, so we're talking about the opposite value of a. So let's, on a side note, let's just say a is, for this here, -2. -2 would be less than 0, yes? So here we're saying that negative a. So that would be negative, well, a is what? -2. So what is negative 2? 2. So if a is negative, it's the negative version of it, the opposite of it, which still means that it is positive. It is never negative. It's an odd way to state this, but if a is less than 2, then we have the opposite value of a. So it'd just be 2. For instance, if a is equal to -5, then the absolute value of -5 is equal to -5, which is just 5. The absolute value of a real number is either positive or 0. Moreover, 0 is the only real number whose absolute value is 0. All right, Jessica. Hey, absolute value of -15. It would be 15. Brooklyn, absolute value of 2/3. Yes. Molly, the absolute value of -4.3. Yes. Abby, almost. Well, the absolute value of -6 would be 6, yes? But then we're taking, so that takes care of what's inside. But that still leaves us with -6. Now the negative, because the absolute value of -5 would be 5. So the absolute value of -6 is 6, but we still have the negative on the outside. Now if we apply it to how we did on the last one, very good, not found. Let's back up. It would be -6, because that there would be the absolute value. Now inside, we would just get 6, which would give us -6. So we take care of the absolute value first, and the absolute value of -6 would be 6, and it goes back to negative because of the negative on the outside. Go back. Let's pull this up here. Second quick. Math. If we click math and go over one to numbers, the first one, ABS, is actually the absolute value. So I'm going to say the absolute value of negative 6 is 6. Negative math. Absolute value. So the calculator will do some of this for us. Now the graphing calculator will do absolute value calculations. Unfortunately, the 30XS will not. The law of trigonometry states that for any two real numbers, A and B, precisely one of these three relationships is possible. Either A is equal to B, A is less than B, or A is greater than B. The only way we can have these here. And we do have these properties. That if the absolute value of A is greater than or equal to 0. Because A has to be positive, that's greater than or equal to 0. The absolute value of negative A, the opposite of A, is equal to the absolute value of A itself. The absolute value of A times B is equal to the absolute value of A times the absolute value of B. And the absolute value of A divided by B is equal to the absolute value of A over the absolute value of B. So these are kind of our definitions here. Make sure we're doing good on time. Yep. Now, we can apply some of these here. We're not going to focus too much on it, especially with the homework. But we'll see with this here. So we want to evaluate the absolute value of the absolute value of X divided by X, or X is greater than 0. So we're looking at it for if the value of X is greater than 0. So that means we're talking about for X being positive numbers, positive values. So if this is true for this here, we know that the value of X on bottom is always going to be positive. Yes? In the top, we're looking at the absolute value of X. Well, the absolute value of positive X is still going to be X. And X divided by X, anything divided by itself is 1, yes? And because it is the same X, they're both positive, they're both going to be positive X, we get positive 1. Questions on this here? All right, let's look at the next case. Where X is less than 0. That means our value of X is going to be what? Negative. So let's signify it. Let's say that this is our negative X, and the top is also going to be negative X. Now the absolute value of negative X, well, the negative is going to become positive. Now there's different ways we can go about explaining it. One is really from the first law here, or this first property, that the absolute value of A is equal to this here. Or we can go in 2 steps, saying that the absolute value of negative A is A. Really, we're just saying that this is just the absolute value of X, which means it's just going to be X. Or we could have just jumped to that. But the denominator is going to stay negative X, because there's nothing being applied to it. Well, X divided by X is still what? 1, yes? But it's not positive 1 anymore, it is now negative 1. Questions on this here? Oh, no wonder. Yep. So we want to evaluate x plus 3, the absolute value of x plus 3 over x plus 3 for A, x is greater than negative 3, and B, x is less than negative 3. So we have two different statements here. Yep. Now, for our first one, A is greater than negative 3. Yes? So we're looking at this in a general sense. Now, let's do a more specific sense, because some of it might be a little harder to see, because here we're saying it's positive or negative. It's one or the other. That's a little bit nicer, easier to see when we're not talking about something else being added to it. So let's get an example to use for this here. So give me a number that would be greater than negative 3. Negative 2. So let's just say x is negative 2. So for us here, we would have what? Negative 2 plus 3 inside the absolute values over negative 2 plus 3. Now on top of the fraction, negative 2 plus 3 would be what? What is negative 2 plus 3? 1. And we'd have the absolute value of 1. On bottom, negative 2 plus 3 is 1. Yes? Which would just give us 1 over 1, which is 1. And we could try the same thing with negative 1. Or, here's all this here. Or, now you can say 19, because 19 is greater than negative 3. 19 plus 3 would be 22. On the bottom, it would be 22, which would just be 22 over 22, which is 'So we kind of see how this works, yes? Now, let's talk, erase all this here. In the general sense, if we know about this here, so we have x plus 3 over x plus 3. If x is greater than 0, we know that essentially this is just going to be a positive x over positive x, which is 1. So this here, if x is greater than a negative 3, this will work out to be just 1. What do we think will happen if x is less than negative 3? Because if we do that, and we can just pick a case, a negative 4 plus 3 over then, not what I wanted. Okay, yep. Negative 4 plus 3 over negative 4 plus 3 would just be the absolute value of negative 1 over negative 1. Yep, so it just works out to be negative 1. That's it, because we know that x plus 3, since x is going to be greater than negative 3, the bottom is going to become negative, and what's inside the absolute value would also be negative. But since we're taking the absolute value of something that is negative, it's going to become positive, and then we'd have positive divided by negative, giving us a negative 1. Questions on this here? And there are other things that we can get more complicated than that, but we're not going to focus too much on those. Who wants to go first on putting the proper greater than, less than, or equal to? Go. Negative 4 is greater than 3 because the absolute value of negative 4 would be 4. Absolute value of 3 is 3, so it would be greater than. Who wants to go next? Yes. Because the absolute value of negative 10 would be 10. Absolute value of 10 is still 10. So they would be equal to. And the last one, negative absolute value of negative 7 and the absolute value of negative 7. Nothing. Because the negative absolute value of negative 7 would be negative 7. Absolute value of negative 7 is still 7. So really we're saying negative 7 is less than 7. Here 10 is equal to 10. And here 4 is greater than 3. Absolute value. We're going to stop here. We'll pick this up tomorrow. And it's not going to take us all hour, I don't think, to finish this. Because we're on slide 29. 56. But most of that we're going to end up skipping through.